All right, let's look at a problem here. This one, we've got y equals x times the cosine of 5x minus sine squared of x, and we need to find d squared y over dx squared. In other words, we have to find the double derivative of y with respect to x. Okay, in order to find the double derivative, we need the first derivative. So let's do that. So dy dx is going to equal, and again, I've got x cosine 5x, so I need product rule. I've got 1 d2 plus 2 d1. So that is x times the derivative of the cosine of 5x plus the cosine of 5x times the derivative of x. And again, this is with respect to x. Minus the derivative with respect to x of the sine squared. Okay, so that means then I need the chain rule for the cosine of 5x as well as the chain rule for the sine squared of x. So I'm going to have a let statement with two different variables. So I'm going to let u equal 5x here, and I'm going to let v equal the sine of x here, which means then that I have the derivative of y with respect to x equaling x times the derivative with respect to x of the cosine of u plus the cosine of 5x times the derivative of x with respect to x, that's 1, so I took that derivative, minus the derivative with respect to x of v squared. Okay? Now, I've got two derivatives to take as the operators are noting here. So I have dy dx equals x times the derivative of the cosine of u with respect to x plus the cosine of 5x times 1. Derivatives are done in this term, minus the derivative of v squared with respect to x. Okay, so now I've got x. The derivative of cosine is opposite sine. Don't change the variable. I took the derivative of the cosine in terms of u. Now my derivative is in terms of u. But I just took the derivative of something in terms of u, and I need it with respect to x. That's where that operator comes in. I need a du dx here to bring me back into terms of x. So my derivative for this first term is done. Okay? Plus cosine 5x minus, now I'm taking the derivative of v squared with respect to x. That's going to be 2v. And again, I just took the derivative of something in terms of v, but I want it with respect to x. I got to make sure I have an operator to bring it back to the right terms. That's where the dv dx comes in. Okay, I'm going to keep going. Now, I've got opposite x sine u times the derivative of u with respect to x. So what was u? U was 5x from the let statement, plus cosine 5x minus 2v times the derivative of v with respect to x. What was v? V was the sine of x. Okay, moving right along then. I've got operators here. I've got to still take derivatives. So I've got opposite x sine u times the derivative of 5x with respect to x, and that's going to be 5, plus cosine 5x minus 2v. Now the derivative of the sine of x with respect to x is cosine x. So in this step, there are no operators present. That means all of the derivative taking has been done. The last thing I would like to do is make sure everything is in terms of x. So I have opposite x, sine of what was u was 5x, so opposite x sine 5x, still times 5, plus cosine 5x, minus 2, what was v? V was sine x. That means we got cosine x here. Believe that's a trig identity, 2 sine x, cosine x. I think that's sine 2x. We'll change that here in a minute. So clean it up one more step. I've got negative 5x sine 5x plus cosine 5x. Okay, and then I've got minus the sine of 2x. Okay, because again, 2 sine x, cosine x, that's the sine of 2x. That'll be easier to take the derivative of when we get there, because we need to take the derivative of this, and we're going to need that chain rule embedded here. So right now, what do we got? We got the first derivative. Okay, we've got the first derivative. All right, so I'm going to erase this. I'm going to move this first derivative up because we have to take the derivative again. I'm going to need some more board space. Let me grab an eraser. Okay, so I've got a more complicated function now to take the derivative of, but I have to take it again. The relationship of the first derivative to the second derivative is the same as the function to the first derivative. We're operationally just going to keep going. So I've got dy dx equals negative 5x sine 5x plus cosine 5x minus sine 2x. Okay, and that's what we need to take the derivative of. Here's our first derivative, dy dx. And again, as complicated as it is, it's the instantaneous rate of change to the original function, okay, and again, relative to our Cartesian plane. Okay, so let's do the derivative again. Now I'm going to find d squared y over dx squared. Okay, so I've got negative 5x sine 5x. I need my product rule here, 1d2 plus 2d1. So I've got 1 negative 5x times the derivative with respect to x of the sine of 5x. Looks like I need the chain rule for that piece. So I've got 1d2 plus 2, so that's sine 5x, times d1, that's the derivative of negative 5x. So I got 1d2 plus 2d1, that's the derivative of that first part, and I say the first part, that's just the derivative of this product. That's everything here. Okay? All right, we still need to take the derivative of the cosine of 5x. Okay, the derivative of the cosine of 5x, we need the chain rule. Okay, let's do this one in our head. If we let 5x equal u, we would have cosine of u. The derivative of the cosine of u is opposite sine u. But knowing how the chain rule works, I just took the derivative of something with u in it, and I need it with respect to x. So we need that operator, du dx. Okay? Similarly, I'm going to do the same thing with the sine of 2x. I would have a u in this case be 2x. The derivative of the sine of u is cosine u, but we need a derivative of the 2x as well. So that's where we would need the du dx. Now I know we just kind of did those in our head. Okay, the math people are not going to like that I used the variable again, so I'll just call this one v here to appease every mathematician in the world. So I've got now another variable there, but again, that was the chain rule at work without formalizing it with the let statement. Okay, so let's see what we have. We've got opposite 5x. Now the derivative of the sine of 5x, that's the same thing as we just did with cosine. So the derivative of the sine of 5x is cosine 5x times the derivative of 5x. So it's cosine 5x times 5. Plus, I've got the sine of 5x. The derivative of negative 5x with respect to x is negative 5. Okay. Minus sine of, it was what? 5x for that u, because that's where it came from, the derivative from here, that cosine. This u was a 5x, and then the derivative of u is a 5 with respect to x. Minus cosine 2x times the derivative of 2x. So that's a 2. Okay, and again, we can notice in this step, there are no operators. All of the variables are x. We have the derivative, or in this case, the double derivative to that original function y, or we have the first derivative to the first derivative, if you wanted to think of it that way. Okay, so let's see if we can clean this up a little bit. I've got a 5 and a negative 5, so it looks like I got negative 25x cosine 5x minus 5 sine 5x minus 5 sine 5x minus 2 cosine 2x. Okay, so looks like we got the same terms here, so we can combine those. Negative 25x cosine 5x minus 10 sine 5x minus 2 cosine 2x. And there is the double derivative to the original function x cosine 5x minus the sine squared of x. Okay, and again, the double derivative is the derivative of the first derivative to the function. Okay, and if you want to think of it as the instantaneous rate of change to the first function, you can, because the relationship is preserved. And again, these functions are just functions of one another when we take the derivative. And here we've got the double derivative, and again, everything's in terms of x. We've got some multiple angles to deal with, and offhand, I don't see a trig identity to swap it out. Your problem would have had a slightly different answer had you not used that double angle identity within that first derivative, but again, we do have an expression for the double derivative here. Okay.